Over 19,000 have been located. Hitherto unknown underwater mountains and volcanoes. The world below sea level is poorly understood. This is perfectly demonstrated by the latest research of the seabed, in which, thanks to the use of satellite radar data, 19,000 hitherto unknown underwater mountains and volcanoes were discovered. We usually learn about underwater volcanoes when they manifest their existence in a spectacular way, through an eruption. Meanwhile, as it turns out, there is a method by means of which we can detect them even before they emerge from the water. And on a massive scale. A team of oceanographers from the Scripps Institution of Oceanography, in collaboration with scientists from Chungnam National University and the University of Hawaii, discovered 19,000 previously unknown underwater volcanoes or mountains. This work is critical to better understanding the ocean floor, improving modeling of ocean currents and ensuring safer underwater navigation. The description and results of the research were published in the journal, Earth and Space Science. Researchers from these institutions have succeeded in developing a method for mass detection of underwater volcanoes and mountains. But to understand exactly what it is, we must first look at how the ocean floor is shaped and why it is so important to know it thoroughly. On dry land, what stands out in the landscape are, of course, the mountains. And their counterpart in the form of undersea or seamounts also exists at the bottom of the ocean. They are formed either as a result of tectonic movements or volcanic activity. However, the existence of seamounts is not completely without influence on human functioning. Considering the fact that so far we have mapped only about 25% of the world with sonar ocean floor, we know very little about where they might be. And this, in turn, can be a problem for submarines, for example. There have already been cases in which, for example, American ships collided with such mountains. This is also a problem for scientists who are unable to accurately predict the directions of water flow in the oceans. Because when sea currents hit such a place, the water carried by them is pushed upwards. Experts set themselves a rather difficult task of discovering as many seamounts as possible. For this purpose, they decided to use data collected by radar satellites. Of course, they do not serve this purpose in themselves, but you can use the fact that they measure, for example, the height of the ocean surface, which in turn changes depending on the gravitational pull associated with the topography of the bottom. And in this way it became possible to find as many as 19,325 previously unknown seamounts, i.e. potential volcanoes. The discovery extended a previously published catalogue of 24,643 seamounts to a total of 43,454. In addition to the benefits listed above, discovering so many mountains can also be useful for the mining industry. This is because in such places you can often find significant amounts of rare minerals. However, it will also serve to better map the course of tectonic lines, as well as the geomagnetic field. It will also be important for the study of the underwater ecosystem. Because the vicinity of underwater mountains is also a friendly environment for ocean fauna and flora. Can the hair graying process be reversed? New discoveries of scientists. New York scientists say that in a recent study on mice, they discovered a previously unknown mechanism of hair graying. Their findings could lead to the development of a therapy that halts or even reverses this process. For many people, the fact of changing the color of their hair is a source of significant discomfort. That is why a thorough understanding of the mechanism behind it is so important. The ideal solution would be to find a method to stop this process in the process. And it seems that scientists from the New York University Grossman School of Medicine took a step in this direction. In new research, they have found that melanocyte stem cells, which are responsible for producing pigment in the hair, can get stuck, lose their ability to move as the aging process progresses, resulting in inhibition of their maturation and maintenance of hair color. The description and results of the research were published in the journal Nature. Why does our hair turn gray? This is due to the fact that the resources of specialized and pigment-producing cells, i.e. melanocytes, are simply shrinking. At least that's what was thought until now. Scientists in New York looked closely at this process to better understand it, which resulted in the discovery of a hitherto unknown mechanism. The results of their analyses show that it may be possible to reverse the graying of hair. The researchers focused their research on melanocyte stem cells. Their immature versions are located in the hair follicles. They move from one part of the bellows to another. There, stimulated by proteins, they mature and produce pigment. By analyzing hair cells in mice, the researchers found that these cells moved back and forth in the hair follicle. They matured, produced pigment and returned to the initial phase. It seems that over time, a plug forms in the path of these cells, somewhere in the bulge of the hair follicle. Cells can get stuck there for good, as a result of which they do not receive protein signals and do not turn into enough melanocytes for our hair to maintain its color. The researchers looked at how this process works in mice and noticed that in their case, aging caused the amount of stuck cells to increase from 15% to 15%, to almost half. At the same time, they remained in this place, neither regenerating nor transforming. If the existence of a similar mechanism were also observed in humans, it would have the potential to reverse this process by simply unloading the plug, i.e. releasing the stuck cells. This study adds to our basic understanding of how melanocyte stem cells function and how they give hair color, said Chi Sun, lead author of the paper. The newly discovered mechanisms have been observed in rodents, but it is likely that the same mechanisms may also be present in humans. If so, we have found a potential avenue to reverse or prevent hair graying by helping block cells reroute around the hair follicles, he added. First science data from the JUICE spacecraft. The European space probe Jupiter Icy Moons Explorer, JUICE, made the first scientific measurements by recording the magnetic field, ESA and POLSA in form. The JUICE probe was launched into space on April 14 this year, from the spaceport in French Guiana. It is currently in the process of deploying and activating its booms, antennas, instruments and sensors. These procedures will take several more months. On April 21, the boom of the J-Mag magnetometer was deployed. This happened when the probe was 1.7 million kilometers from Earth, according to POLSA. The data recorded by J-Mag shows, among others, the moment the boom is deployed. Before unfolding, the instrument recorded changes in the magnetic field in the immediate vicinity of the probe, and when fully extended to 10.6 meters, it already records the magnetic field carried by the solar wind. In-depth testing of the instrument will begin next week. There are also radio and plasma wave investigation (RPWI) instruments on the boom. According to scientists from the Space Research Center of the Polish Academy of Sciences, the first recorded signals indicate that the device is working properly. In the following days, 4 extension arms of the Langmuir probe's plasma parameters analyzer will be deployed, and then the components for electric field diagnostics will be tested. When the spacecraft reaches Jupiter in 2031, the J-MAG magnetometer will be tasked with measuring the planet's magnetic field and its interaction with the magnetic field of Ganymede, Jupiter's largest moon. In turn, RPWI will study the radio emission and plasma environment of Jupiter and its moons. In total, there are 10 scientific instruments on board the JUICE spacecraft. The JUICE project is led by the European Space Agency, ESA. It is the largest mission in ESA history. The goal is to study Jupiter and its icy moons Ganymede, Europa and Callisto, including exploring the moon's supposed subsurface oceans. The project led by ESA involves 18 institutions, 23 countries, 83 companies, 116 industrial contracts were signed. Over 2,000 people participated in the work, and the cost of the mission is approximately €1.6 billion.